Hi, this is Dr.Un, and we are going to do some lessons on factoring today. So this is factoring lesson 3. We are going to factor two terms, the special cases. Remember the rules of factoring. First, you should always look for GCF, pull out the common terms, and then we decide if it's 2 terms, 3 terms, or 4 terms. 2 terms is today's lesson for the special cases. These are the major ones that your teacher probably want you to remember, and you're going to need to practice this a little bit because they are not going to give this to you during the test time. So the first one is sum of squares. If you look at here, you have a sum and 2 squares here. And in the intermediate algebra level, we are going to say this is actually not factorable. This is prime, so the factor for this would be still a squared plus b squared. So this is prime, meaning not factorable. But when you go to college algebra, they're going to tell you something else, but we don't worry about this at this moment. Okay, the second one is a very popular one, is the difference of 2 squares. So you see a difference here and 2 perfect square. When you factor this, what I do is I look at this and I say, okay, I'm going to write what I see here, a minus b without a square, and then it comes with like twins. So you have the a plus b too. And some people may write a plus b times a minus b. The order doesn't matter because 2 times 3 is the same as 3 times 2. So when you multiply things together, the order doesn't matter. The next one is sum of 2 cubes. And the difference of 2 cubes, they are a little bit more difficult to remember. And I'm going to try to help you. So what I do here is, for the sum of 2 cubes, first you will write down what you see here without a cube. So you have a plus b. And then I say I'm going to have my sandwich. So the first guy needs to be square, a square. And the last guy needs to be square, which is b squared. And in the middle of it, you will pick one of each. So you have a and b. And the sign is going to be SOAP, S-O-A-P, meaning first you will have the same sign with the sum of 2 square, and then you have opposite sign of sum of 2 square, and the last term is always positive. So the sign we remember S-O-A-P, SOAP. Same, opposite, always positive. So if you can remember the sum of 2 cubes, it would be similar for sum of 2, difference of 2 cubes. So for difference of 2 cubes, first we will write down what we see without a cube. So it's going to be a minus b. And then my sandwich, so it's going to be the first term square, the last term square, the middle part is one of each. And the sign is going to be SOAP, S-O-A-P, meaning same as this, the difference of 2 cubes, opposite with that, so it's going to be at, and the last term is always positive. So practice this, and you will need this and be able to apply it during the test. So we're factoring with 2 terms special cases. First, we will check and see if there's any common terms we can pull out. If not, this looks like the sum of 2 squares. Just to be sure, I can do it on the side. This is some square plus some other square, which is true because this is x squared. X times x is x squared. And 3 times 3 would be my 9. And we say sum of 2 squared is prime, meaning not factorable. So the answer for this will still be x squared plus 9. We cannot factor this in intermediate algebra level. And the second example, we are factoring this. First, we check and see if they have any GCF to pull out, and I don't see any. And the second part, we notice we have 2 terms, so it's one of the special cases maybe. And it looks like we have a square at the beginning and a square at the end and subtraction in between. So I think it may be a difference of two squares, and I want to double check. Is it some square minus some other square? So we can think 64, what square would be 64, and it's actually 8. And x times x would be x squared, so 8x squared will give me 64x squared. And the second part, we are thinking what square would be 49, and it would be 7y. So 7y times 7y will give me 49y squared. So it's kind of an a squared minus b squared here. A squared minus b squared, it should be a minus b times a plus b. And I can see here my a should be 8x. And my b should be 7y. So I can apply my difference of two square. So the answer will be a minus b times a plus b. And my a is 8x. My b is 7y. 8x and 7y. So if you want to check, you can FOIL this out and it should give you back the question. So that's number 2. And example 3, we look at here, we see sum, and then it looks like there's a cube here, and it's factoring with 2 terms. So we wonder if this is sum of 2 cube. And we want to double check, so see if this is some cube plus some other cube. So we're thinking what cube make m cubed, so clearly this is going to be m times m times m. And then what cube would be 125, and it's actually 5 times 5 times 5. So 5 cubed will be 125. This is sum of 2 cubed. Remember, we have the sum of 2 cubed. Let's try to remind you here. Sum of 2 cubed is going to be a cubed plus b cubed, which we write down what we see here without the cube, a plus b. And then the sandwich, meaning this first term square, last term square, middle part is one of each. And the sign is going to be SOAP, right? So it's same, opposite, always positive. And we can see that our A is M and our B is 5. So when we apply that, first we write down this without a cube, so M plus 5. And then we have the first term need to be square. The last term need to be square. And the middle one is one of each, so it's 5m. And the sign is going to be same as the top, opposite with that. Last term is always positive. And don't forget, here we are not done because we have a 5 square here, so we need to multiply that out. So the final answer will be m plus 5 times m squared minus 5m plus 5 squared is 25. So that would be the answer for number 3. That is an example of sum of 2 squares. And when we're ready, we are going to number 4. Number 4 is a little bit more complicated because it looks like different, and it has square and also cube. So we need to decide if it's different of 2 square or different of 2 cube. But we have the first rule of factoring is what? Factoring, the first rule is we need to pull out the GCF, and both of these have a squared. So you need to remember to pull out the a squared first. And after you pull out a squared, you still have 8 minus b cubed. So now it's more obvious this is the difference of maybe 2 cubed. We want to double check to make sure this is true. So don't forget you have an a squared hanging out outside. And we want to double check and make sure this is some cube subtracting some other cube. So the first cube, we think, okay, what times what is 8? And it turned out it's going to be 2 times 2 times 2 is 8. And of course, b times b times b is going to be b cubed. So your difference of 2 cubed, a cubed minus b cubed, turn out to be your a is 2 and your b is b. Okay. Now we need to use our difference of 2 cubed to factor this out. So again, your a squared is still hanging outside. So just leave it there. And then first, we are going to write down what we see here without the cube. So it's going to be 2 minus b. And then my sandwich. So meaning that the first term needs to be square, which is 2 squared. And then the last term needs to be square, which is b squared. And I need one of each. So it's going to be 2b. And the sign is going to be sub, right? So it's going to be same here with the difference of 2 cubed. Opposite of that, the last term is always positive. And are we done? Not really, because there's still 2 squared, right? So we have to write one more time. The final answer will be a squared times 2 minus b. 2 squared is going to be 4. Plus 2b plus b squared. Difference of 2 cubed and sum of 2 cubes seems to be more difficult for my students, so you may need some more practice in order to be very good at this. And here is example 4.